Hello everyone, I'm Paul and today we're solving problem 2598, smallest missing non-negative integer after operations. This is an easy one and the key to solve this is observation. So let's start. We are given an integer array nums and an integer value. So let's say this is nums and value is 5. And we can add or subtract value from any element of nums any number of times. And our job is here. We need to return the maximum smallest missing non-negative integer in the array after applying this operation any number of times. So if after applying the operation any number of times we get this array, we return 2, because 2 is the first non-negative value that we can find in this array. We have 0, we have 1, but we don't have a 2, so we return 2 in this case. So if we are given this and we are trying to get the maximum missing non-negative integer, this means we can try to get a 0, then we can try to get 1, then we can try to get a 2, and so on. And whenever we can't get a number, we just return that number. So let's start with 0. How can we get 0 in this array? Remember, we can add or subtract value any number of times from any element. So we can add a 5 here and the result is minus 5. We add 5 again and the result is 0. Now we have 0 and we are trying to get 1. Well, we already have 1 here, so we continue with 2. We could subtract 5 here and the result is 2, so we continue with 3. We could subtract 5 here, the result is 8. We subtract 5 again, the result is 3. So now we have 3 and we are trying to get 4. If we remove 5 from here, the result is 1. And if we remove 5 from here, the result is 3. So there's no way to get 4. And given that we can't get 4, we return 4 for this input. So let's analyze this. We need to get the maximum smallest missing non-negative integer. So we start from 0 and we are trying every integer that's greater or equal to 0. So it would be great if we could somehow transform every element in this array into the minimum or the smallest number that's greater or equal to 0, meaning the smallest non-negative integer. And how can we do this? Well, for example, here we took minus 10 plus 5 and plus 5 again, and the result was 0. But the question is, how can we go from minus 10 to 0, knowing that this is the value? And the answer is, we can take minus 10 modulo the value, which is 5. And the result for this is 0. So we are skipping every operation in between and we go from minus 10 to 0. And what this 0 represents is that with this element we can get 0, 5, 10, 15 and so on. And we can also get minus 5, minus 10 and so on. Okay, so now I think you get the idea. We can use this element to get all of these numbers. Now we only care about non-negative integers, so we can forget about this negative part and we are using this element to get any of these numbers and more. So from this value we get the minimum non-negative integer, which is 0, and we add any number of values. Okay, so value times k. And just to make this clear, if we reduce 6 with this value, we get 1. If we reduce 8 with this value, we get 3. And if we are solving this again, we have only one way to get 0, which is to take this. And we have two ways to get 1. We can either pick this or this. It's exactly the same. Now let's say we have these 3 elements and we reduce this. So with this value we still have a 4. If we reduce this with this value we have a 0, and if we reduce this we have a 1. And let's say we're doing the same. We start from number 0 and we can get number 0 from here or from here. It's the same. Let's say we pick this. Now we can get 1 with this or this. Let's say we take this. So we do the same with 2. We can only pick this. And we do the same with 3. We can only pick this. We only have a 4. And now we are trying to get 5, but here we have a 0. So we need to speak the same language. So before searching for each of these numbers, we can transform this in the same language, meaning we take each of these, in this case 5, modulo the current value, which is 5. The result here is 0. So we are looking for another 0 here. And here we have another 0. So we can get 5 also. Now we are trying to get 6, but here we have a 1 because we are speaking different languages. So we take the current number 6 modulo the value 5, and the result is 1. So we are actually looking for a 1, and here we have a 1. So we take this and we can get 6. Now we are trying to get 7, meaning 7 modulo 5. This is 2. And given that we don't have any available elements here, we have already used all of these to get these numbers. We can't get 2, so we return the current number, which is 7. So as you can see, we only care about how many zeros do we have, and how many ones do we have, how many 2's, and so on. And for this we can use a frequency map. In case you don't know what a frequency map is, we can iterate this from left to right, and every time we take the current value modulo value, and that's the key for the frequency map. So first we are here, 1 modulo 5 is 1, so we put 1 with a count of 1. What this means is, up to this moment, we've seen number 1 only once. Now we are here, so we take minus 1 modulo 5, the result is 0, so we put 0 as a key, and the value for this is 1. Next, here, 7 modulo 5 is 2, so we put 2 as a key with a count of 1. Next, here, we put 3 with a count of 1, and so on. For example, here we have a 0, so the count for 0 is 2, and here we have a 1, so the count for 1 is finally 2. So this is the final frequency map. So now we can iterate this once again and get the result. We are trying every number from 0. So we try every non-negative integer. And first we do 0 modulo 5, the result is 0. So we are checking in the frequency map if we have a 0. And we have 2 instances of 0. So we continue with the next number and we update this to 1. Next, we want to get number 1, so we do the same. We check if we have 1s available. We have 2, so we use 1. This is now 1. And now we are looking for 2. 2 modulo 5 is 2, so we are looking for 2's here. We have 1 available, so we are using this. This is 0. And we continue with the next number, 3. 3 modulo 5 is 3, so we are looking for 3 here. We have 1 available, this is now 0, we continue with 4. 4 modulo 5 is 4, we have 1 for here, so this is 0, we continue with 5. And 5 modulo 5 is 0, so we are checking if we have a 0 here. And we have 1 0 available, so this is now 0, and we continue with 6. 6 modulo 5 is 1, so we are checking if we have a 1 available, and we have it right here. So this is now 0, we continue with 7. And 7 modulo 5 is 2, and we are checking if we have a 2 available, and the count for 2 is 0, so we can't form a 7, so we return this. So this is the entire approach. Time and space complexity here will be big O of n. And with this in mind, let's go with the code. This is a very short code. First, we need to build a frequency map. So this is a default dictionary with a default value of 0 for every key. That's why here we use the word int. And now for every number in nums, frequency map at the current number modulo value, remember this is very important, plus equal 1. We start from number 0 and we can say while true, if frequency map at the current number modulo value is equal to 0, we return the current number right away, meaning we can't get this number, so we just return this. Else, frequency map at number modulo value minus equal 1. And every time we add 1 to the number. So this is the entire code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.